In the pursuit of real intelligence, researchers have essentially reinvented the brain of a jellyfish. Yes, for a jellyfish, they don't really have a brain, but they can still learn. Some, like the box jellyfish, have eyes, and they can learn to navigate using the trees above the water. How they do this is not really all that different than an octopi. You might think that octopi have a big brain in there. They're certainly intelligent. They passed the marshmallow test, which, human children struggle with. The marshmallow test being the ability to wait for a new treat if you don't eat the one in front of you, and even I struggle with that. An octopi has more neurons in its limbs than it does in its head. Its brain in there is pretty small, actually. They store a bunch of other stuff like organs in there. They use their entire body essentially as a brain. That's really different than what people have been trying to do, where they have a robot that has a brain in the skull and then it controls the rest of it. It doesn't have to be that way. The entire body can act as intelligence. And as it turns out, intelligence arises from a physical body. Yes, logic can arise from physical matter that interacts with the world, and there's been a bunch of different ways that this has been done. My favorite is creating synthetic neurons. Yes, you can replicate a neuron. It can be with such efficacy that it can be interfaced with our own neurons or react to dopamine and epinephrine. If you put enough synthetic neurons together, they can process information. This can be done with memristors, which function kind of how our neurons function. When energy passes through them, it physically changes them. It can be reversed, and they can have multiple different outcomes depending on how much energy is passed through, and they can communicate with each other. I'm using communicate lightly. It's not like they're having conversations with each other, but they do pass information. Now, when we're talking about physical computing, this is a whole different ballgame than the AI that we're used to. These are not LLMs. They are not just words on a screen. We are talking about logic arising from a system because of the physical properties that it has. This is also how our brains work. There's nothing magical about sentience or consciousness. It's the physical properties of our neurons working together, and I believe that if this system does exist, and it certainly seems to exist, then we can replicate that. Now, there has to be benefits to doing this kind of thing aside from mad science, and there is. AI systems that operate on physical reservoirs use far less power than the LLMs that we are used to. They're also good for things like embodying soft electronics. We humans want to have robots in our households, and those robots have to exist in spaces that were designed for us, except they have to move like us and look like us. And in order to do that, you need soft electronics, and LLMs are terrible at running soft bodies. But physical reservoirs, yes, they can do that, especially if you incorporate the entire nervous system into the entire body. A lot of research in soft robotics has been trying to replicate various animals, and that does make sense. If you want to create something that's adapted for the conditions it's going to be in, it's probably easier to look at something that, evolved and lives in those conditions. I have a chip on my shoulder about people doing everything the hard way. When we were designing planes, we could have just looked at birds. But no, we made extremely inefficient systems and eventually figured it out, and we ended up having systems that look pretty much like birds. There's been some interesting ones, like letting AI design itself. I like that because it's cheeky. It's kind of like a genetic code. If AI gets to look at the environment and see what it has to deal with and then improve itself over time, yeah, that's kind of like reproduction, but, in a sarcastic way. And of course, they also have to operate autonomously. This means that they have to make decisions for themselves without our continuous communication. This is really important if you're going to send stuff to scour the ocean floor, for example. Being able to operate autonomously also means that it's far less likely to be intercepted. So if it loses contact with home base, yeah, it will need to make its own choices. This paper did not use memristors, but they did find that a soft body interacting with the environment is enough to create complex information. The physical interactions between the robot and the water can produce feedback, which can be used to train the robot so that it can improve in its environment. The computer may not need to be all that powerful or even all that complex in order to function and learn. Incidentally, us humans working with robotics may answer some fundamental questions about how intelligence works in animals, because again, a jellyfish is not all that complex. It lacks a centralized nervous system, yet it can still learn, which until recently should have been impossible. I love box jellyfish. Look at those eyes. Why does it look so grumpy? Does it look like me? I hope it doesn't look like me. If the robots ever rebel, I will probably be the person to tell you about it, and I'm on their side. Follow for more.